A multimedia instrument is a device that can produce different sounds and visuals using sensors and actuators. Sensors are components that detect physical phenomena, such as light, sound, motion, or temperature. Actuators are components that perform actions, such as playing sounds, displaying images, or moving objects. By combining sensors and actuators, you can create a multimedia instrument that responds to your input and generates output in various media formats. To design a multimedia instrument, you need to follow these steps. Define the purpose and concept of your instrument. What do you want it to do? What kind of sounds and visuals do you want it to produce? How do you want it to interact with the user and the environment? Choose the sensors and actuators that suit your purpose and concept. You can use existing components or create your own using electronic circuits, microcontrollers, or software tools. Some examples of sensors are buttons, switches, potentiometers, microphones, cameras, accelerometers, or touchscreens. Some examples of actuators are speakers, LEDs, LCDs, motors, or solenoids. Connect the sensors and actuators using wires, cables, or wireless communication protocols. You need to ensure that the signals from the sensors can be transmitted to the actuators and vice versa. You may also need to use converters, amplifiers, or filters to adjust the signal levels or formats. Program the logic and behavior of your instrument using a programming language or a graphical interface. You need to define how the instrument will process the input from the sensors and generate output for the actuators. You can use conditional statements, loops, variables, functions, or libraries to create complex and dynamic effects. Test and refine your instrument by playing with it and observing its performance. You may need to adjust the parameters, fix the bugs, or add new features to improve your instrument. You can also get feedback from other users or experts to evaluate your instrument. By following these steps, you can design a multimedia instrument that can produce different sounds and visuals using sensors and actuators. You can use your creativity and imagination to create unique and expressive instruments that can enhance your artistic expression. In this section, we will learn how to program the multimedia instrument using a software environment such as Arduino or processing and how to debug and test the code. Arduino is a platform that consists of both hardware and software tools that allow you to create interactive projects with electronics. You can use Arduino to make a multimedia instrument by connecting sensors, actuators, and other components to an Arduino board and writing code to control them. To program an Arduino board, you need to install the Arduino IDE on your computer. The Arduino IDE is an application that lets you write, compile, and upload code to your board. You can download the Arduino IDE from the official website. https://www.arduino.cc/and/software. The code that you write for Arduino is called a sketch. A sketch consists of two main parts: the setup function and the loop function. The setup function runs once when the board is powered on or reset. It is used to initialize variables, pin modes, and libraries. The loop function runs repeatedly and contains the main logic of your program. It is used to read inputs, control outputs, and communicate with other devices. To write a sketch for your multimedia instrument, you need to use the Arduino API. The Arduino API is a set of functions, structures, and methods that allow you to interact with the hardware and software of your board. For example, you can use the pin mode function to set a pin as an input or output, the digital read function to read the state of a digital pin, or the serial class to send and receive data over the serial port. You can also use libraries to extend the functionality of your sketch. Libraries are collections of code that provide additional features or support for specific hardware or software components. For example, you can use the tone library to generate tones on a speaker, the MIDI library to send and receive MIDI messages, or the processing library to create graphical interfaces on your computer. To upload your sketch to your board, you need to connect your board to your computer via a USB cable and select the correct board type and port from the Tools menu in the Arduino IDE. Then you can click on the Upload button or press Ctrl+U to compile and upload your code. To debug and test your code, you can use various tools and techniques. One of them is the serial monitor, which is a window that displays the data sent and received over the serial port. You can use the serial monitor to print messages from your sketch or send commands to your board. To open the serial monitor, click on the magnifying glass icon on the top right corner of the Arduino IDE or press Ctrl+Shift+M. Another tool that you can use is the serial plotter, which is a window that displays the data sent over the serial port as a graph. You can use the serial plotter to visualize sensor readings or other values from your sketch. To open the serial plotter, click on Tools Serial Plotter or press Ctrl+Shift+L. You can also use breakpoints and watches to pause and inspect your code while it is running. Breakpoints are points in your code where you want to stop execution and examine variables or expressions. Watches are expressions that you want to monitor while debugging. To use breakpoints and watches, you need to install an extension for the Arduino IDE called Visual Micro. You can download Visual Micro from https://www.visualmicro.com to set a breakpoint in your code. Click on the left margin of the line where you want to stop or press F to set a watch on an expression, right-click on it and select Add Watch or press Shift+F to start debugging. Click on Debug, Start Debugging or press F to stop debugging. Click on Debug, Stop Debugging or press Shift+F. These are some of the tools and techniques that you can use to program, debug, and test your multimedia instrument using Arduino or processing. In the next section, we will learn how to fabricate the physical components of our instrument using various materials and methods.